Assalamualaikum warahmatullahi wabarakatuh. It be good day for our lecturer for subject EET 208. My name is Mohd Ridhzwan Shah bin Sepian Suri. My matric numbers 1810933667. I am from program AK23, group part-time Kulim. Today I want to present my project simulation and problem solving for EET 208 electric power technology for topic 3-phase Y connected generator. This slide show the resistance and reactance of the loads are given according to metric number as show 67 ohm plus 33 j ohm for transmission loss and 81 ohm plus 9 j ohm for load. Next, introduction. 3-phase electric power is a common method of the alternating current electric power generation, transmission and distribution. It is a type of a polyphase system and is the most common method used by electrical grids worldwide to transfer power. So the current will pass through the 3 wires and there will be the neutral wires for facing the fault current to the earth is known as the 3-phase system. So since the phase impedance of balance Y connected contain the equal current to current, the phase power is 1/3 of the total power. Next, objective. This project objective to investigate and analyze 3-phase Y-to-Y electrical system in the context of the transmission and the load impedance, current, voltage and acceptable voltage drop based on a BS 7671 or any Malaysian authority standard. So this project I will be exposed to regulation enforcement of electrical system in Malaysia for searching certain electrical information. I also will refer to electricity supply application book by Tenaga Nasional Berhad as a reference. As a electrical engineering, knowledge about the electrical rules enforced by the Malaysian Energy Commission, such as Electricity Act, also important for make sure this project can be implemented successfully. Besides that, this project also have to evaluate and analyze the active power absorbed by the loads by using 2-watt meter method and the conventional measuring method. This project objective also familiarized by using PIXIM software. Next, methodology. 3-phase system is a multi-phase system, means it is have a red, yellow and blue indicator supply cable. Also, that means another words line current, and is the most commonly used method in electric distribution grid system for worldwide. So this one Y-to-Y connection circuit, the basic circuit for Y-to-Y connection, and then this one PIXIM software. This one for the 2-watt meter method. Okay, this one flowchart and procedure. Firstly, we finding the value of voltage line frequency, reactance and resistance value, loss and load. Second, learning the PIXIM software, and then construct Y-to-Y connection circuit, and then proof by simulation result, and I get the result and waveform. Another test for using the 2-watt meter method, and then I prove by simulation result and I get the result and waveform. For this one, 3-phase Y-to-Y connection circuit, construct using the PIXIM software. For the inductance, we must convert first from ohm to Henry unit. This one for the result for the line voltage, and then result for the phase voltage, and then the result for load line voltage. This one load phase voltage, and then this one line current. For this slide, I show the 2 watt meter method, and this one for the result active power 1, and then this slide for active power 2. This one for the conventional method. This one the result for conventional method. This one power factor by using the PIXSIM software. For this one slide, I want to show the calculation by theoretical formula. So I get the rated voltage for generator is 33 kV. So to get the voltage, V phase equal to V line divided by Z3. So the answer is 19.05 kilovolt. So next, I find to line current. I line equal to V phase divided by Z impedance line plus impedance load. So by calculation, I get answer 123.8826 with negative 15.84 degree. And for current B, the same magnitude but different angle, negative 133.84 m, and for the current C, the angle is 104.16 m. So the table below show the calculation, the result by using the PIXSIM lab. For next, I find the load phase voltage. So current multiply with the impedance load. So the answer is around 10 kV with negative 9.4998 degree. And for the load phase voltage for phase B, same voltage but different angle is negative 129.4998, and voltage for phase C, the angle is 110.5002, and the table below show the result by using the PIXSIM software. Next, I find the power factor. So power factor equal to cos theta. So I get the 0.993 line or phase current leads the load phase voltage by the power factor 0.993, and the measure as the below, the power factor by using PIXSIM software, I get 0.977. For the next, I find for conventional method, power equal to phase voltage multiply with line current cos theta. So the total active power
equal to PA plus PB plus PC. So the answer is 1241.76 kilowatt. Since the system is balance generator and balance load connection, PA equal to PB equal to PC. So we find for the single phase at the phase A, so we can multiply with 3 phase. So the answer the total of power is 3725.28 kilowatt. The tables below show the result by the BitSim software. For next, 2 watt meter method. So the active power for voltage load line 17.47 for magnitude with the 20.5 degree. For the voltage load line for phase B, the magnitude is same but the angle are different. Is negative 99.5. And lastly, for the phase C voltage load line, the angle is 140.5. For next, to calculate for the power P1 and P2. So for P1, the answer is 1743.16 kilowatt, and for power 2 1982.29 kilowatt, and for the power total B plus for the P1 P2, and the total is 3725.29 kilowatt. And the tables below to show the calculation by using BitSim software. For voltage drop percentage, V drop equal V supply minus V load divide by V supply and multiply with 100%. So the answer is I get it 47%. From the result obtained, the simulation value are less compared with the result from the calculation by the theoretical formula. I can compare the active power, voltage and current from the result, get it a different value, and I also can find the problem during design and construct the 3-phase balance Y-to-Y connection system by simulate the sine wave form from the circuit electrical system. I must understand they are using 2 watt meter method and conventional method. To prove the both of the method I get less value of a power factor from 0.977 with 0.993. By the simulation BitSim software, the system show that the value result have the transmission loss and the voltage drop effect from the impedance component in the circuit BitSim software. Okay, next for discussion, when analyzing the balanced 3-phase circuit, the first step is to transform any delta connection into the star equivalence, so that the overall circuit is of the Y-to-Y configuration. A single phase equivalent circuit is used to calculate the line current and the phase voltage in one phase of the Y-to-Y structure. A phase is normally chosen for this purpose
the technique for calculating per phase, average power, reactive power and complex power are the same as the for a one-phase circuit. The total real, reactive and complex power can be determined either by multiplying the corresponding per phase quantity by 3 or by using the expression based on line current and line voltage. The total instantaneous power in balanced three-phase circuit is constant and equal 1.5 times the average power per phase. A wattmeter measures the average power delivered to a load and a potential coil connected in parallel with the load. The total average power in a balanced three-phase circuit can be measured by summing the reading of two wattmeters connected into different phases of the circuits. For the conclusion, I can conclude that the investigation and analyzing three-phase Y2Y electrical system in context of transmission and the load impedance, current, voltage and acceptable voltage drop based on following BS 7671 or any Malaysian authority standard. In this project, solving problem will be exposed to regulation and enforcement of electrical system in Malaysia for searching certain electrical information. As electrical engineers, knowledge about the electrical rules enforced by the Malaysian Energy Commission, such as Electricity Supply Act 477, also important for make sure this project can be implemented successful. Besides that, this project also expose, evaluate and analyze to solving problem the electrical system in the real situation as an electrical engineer. Okay, this my reference. So that's all for my presentation. Thank you.